My video is on the laws of thermodynamics. At a first glance, this might seem like it's really hard, but it's really simple actually. Thermo, as you guys know, means heat, and dynamics means movement. So thermodynamics is just the movement of heat. Alright, so there are four laws of thermodynamics. At first glance, you guys might wonder, like, what is the zeroth law? Like, why isn't it first, second, third, fourth law? Well, that's because initially, there was only three laws, and a while later, when scientists and researchers discovered the zeroth law, they decided that it would be better to put it in front of these other three laws because it was so important, and they didn't want to rename the laws because that would be too confusing. Because historically, there have only been three laws. So the zeroth law says if two systems are in thermodynamic equilibrium with the third system, two original systems are in thermodynamic equilibrium with each other. This is very simple. It can be thought of just like the transitive property. If A equals B and B equals C, then A equals C. It's the same logic. The first law says energy can be converted from one form to another with the interaction of heat, work, and internal energy, but it cannot be created nor destroyed under any circumstances. So this law has two parts. The first part can be illustrated with this formula, which you can use to calculate it. Delta U, change of internal energy, equals Q minus W, where Q is the heat added to the system and W is the work done to the system. The second part of it says that energy can be neither created nor destroyed. It's very similar to the law of conservation of mass, which states that matter can neither be created nor destroyed, because it is the same law essentially, because as Einstein said, E equals mc squared, which basically says that energy and matter are essentially the same thing. The second law of thermodynamics says that the state of entropy of the entire universe as an isolated system will always increase over time. What this means is that entropy basically means chaos or disorder, and this is just saying that the universe is just becoming more chaotic over time. And entropy, it's to explain it further, it just means that more disorder. So in real life, we can increase the disorder of something by melting it, such as ice. If we melt that, it becomes water, and entropy increases. Entropy is described by delta S, by the way. And if you freeze water, you get ice, which is decreasing the entropy. And out of all these laws, the zeroth law says it's talking about temperature. The first law is talking about energy. The second law is talking about entropy. And the third law is talking about entropy and temperature and how it relates. The third law says the entropy of a perfect crystal approaches zero at a temperature of absolute zero. This is just saying what it is, and basically implies that absolute zero is basically impossible to achieve, as is zero entropy. So you guys might be wondering, like, what is thermodynamics and what does it have to do with biology? It sounds more like physics or chemistry. Well, actually, the first law of thermodynamics describes how energy flows throughout biological systems, as in organisms use free energy and convert it into kinetic energy. So energy is never lost. And the second law says that natural processes cannot occur unless there's an increase of entropy in the universe. And here are my citations. Feel free to look at them for extra practice or extra help. Thank you very much.